Beginning recording device. Here we go. What are we doing today? Today we will be doing the programming of the TI-89 thing. Okay, Mike. Okay, I'm recording. By the way, yesterday my mic was off for this period. So guess which period I uploaded? And guess what? I did this first period today. I forgot again. So keep it clean. All right. So here we go. It wasn't clean? That's unfortunate. Yeah. Okay, so let us begin. By the way, this is on YouTube already if you want to see it on YouTube. But have you seen my YouTube in calculus? Yes, you have? Okay, wait, listen up. Guys, shh. Who's been on YouTube and looked up my calculus YouTubes? I already got a whole bunch. Yeah, how do you find them? How do you search for them? You can learn AP, right? Okay, or Calc Page 2009. So, are you seeing one today? No, what I put on YouTube is like a quick summary of what we're doing in class. Oh, video? No, that's next week. Not every Wednesday. Yeah, Wacky Wednesday is not every Wednesday. So, let us begin. What if you want to solve this equation? Today is not about the math. The math is easy today, yes? Well, that's sort of too hard. That's harder than I wanted. All right. What if I want to solve this equation? What would you do? Solve for x. Yeah, subtracting 1 isn't going to help. Factor, right. You can factor this. Can you do it integer-wise in your head? What multiplies to positive 1 adds to positive 2? What are the factors? 1 and 1, right? So this is one of those cases where you have repeated roots. You set this equal to 0, you get negative 1. You set that equal to 0, guess what? You get negative 1. What we call real rational equal roots, right? All right, the math today is quadratic formula stuff, okay? It's not the math today. It's about the programming. Okay, we'll come back to using programming tomorrow to do some other math. All right, but what if it's not that obvious? What if it's this? Is it factorable? No, so what do you do? Quadratic formula. So x equals, how do you do it? Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Right, okay. So we get negative 2 plus or minus rad what? Work this out. What do you got? Yeah, okay, but what's this? What's in the radical? Nobody knows? 4 minus 4 times 2? Negative 4, right. Now, why is that significant? You can't do that? It's illegal? Only in 49 states. In New York State, we get I, yeah. You can get I. What's rad negative 4? 2i. So you get negative 2 plus or minus 2i. All over 2, can you reduce that? Yeah, there's this common factor of 2, factor it out, it cancels to the other 2, negative 1 plus or minus I. Now, what determines whether you get complex roots like this or real roots like this? What determines that? How do you know that without actually solving the whole problem? Is there a way to predict the nature of the roots? Sure there is. When the discriminant, or the word discriminant, b squared minus 4ac, it's a discriminant because it discriminates.
When it's less than 0,
right, when this is negative, because when you square root a negative, right? When this is negative, less than 0, you get complex conjugate roots. Conjugate, what's that mean? If you know one root is negative 1 plus I, the other one has to be negative 1 minus I, okay? So if you know one, you know both. They come in pairs. So when it's a complex case, it's complex conjugate pairs that you get. So there are actually 4 cases I think of. Complex conjugates, and then there are really 3 cases for real roots. Real rational equal, real rational unequal, you can get 2 different factors, right? Real irrational unequal, you can get like 2 plus rad 3 and 2 minus rad 3, that kind of thing, right? Okay, so what I want to do today, what I'm after is writing a program that does this for me. Okay? All right. The first thing it's going to do is going to figure out the discriminant, so we know what kind of roots we're going to get. So let's talk about discriminants a little bit. take a look at the following equations. What if I had x squared plus 2x plus 2 equals 0, the equation we just solved, right? What's the discriminant, and what's the nature of the roots based on the discriminant? I don't want the roots, I just want to know what kind of roots. Now this one we worked out already, right? It's b squared is 4, right? A is 1, b is 2, c is 3. So b squared is 4 minus 4 times a, we did this already, 1 times c is 2. We get negative 4, which is less than 0 or negative. So we get complex conjugates. Okay, that fancy C is complex number set. But what if it's x squared plus 2x plus 1 equals 0? Now b squared is still, I'm not changing the b, so b squared is still 4, right? Minus 4 times a is still 1. All I'm changing is c, and what do I get? 0. Now that's the one we just factored. We got the same answer twice. Okay, I'm going to write it this way. It's real, rational, equal roots. Okay, real, a fancy R for the real numbers, a fancy Q for the rationals, and equal. Why Q? Why is Q the symbol for the rational number set? Because I was already taken, yes, and there's more. Why is Q a good choice otherwise? No. It is, but that's not why. Yeah. Well, because think what a rational number is. Let's go. I didn't write down the quadratic formula yet, did I? Okay, well, what's a rational number? A rational number is a decimal that terminates or repeats. But it also means that it can be written as a fraction, an integer of an integer. Okay? So since I'm doing an integer divided by an integer, it's a quotient. There you go, Q. All right, now try this one. What about x squared plus 2x plus nothing is 0? By the way, can't you factor that in your head? X times x plus 2. So set them equal to 0, you get x equals 0 or negative 2. So it's real, rational, unequal roots. Why? Because b squared is still 4, a is still 1, but c is 0. So you don't get a negative number, you don't get 0, you get a positive result. So it's got to give you reals when you square root it. And it's a perfect square. So when you square root the perfect square, you get an integer in the numerator. Okay. So it makes sense to get rationals. Okay. And how about this one? X squared plus 2x minus 1. So b squared is still 4, a is still 1, but c is negative 1. What do you get? 8. All right, so when the discriminant is positive, but not a perfect square, what happens when you square root it? It's irrational. So real, I'm going to fix this. Hang on. This is 8. Okay, so it's real, and it's irrational, and it's unequal. Notice this symbol means irrational. What do you think it means? Why do you think I wrote that? All the reals take out the fractions, right? If you take out all the fractions from the real number line, what's left are the irrationals, decimals that never end, never repeat. Okay, good. So, what are we going to do with this? Well, we're solving quadratic equations, right? And this is our test case, by the way, for our program. We're going to test it. If we plug in 1, 2, 2, we should get negative 4. If we plug in 1, 2, 1, we should get 0. If we plug in 1, 2, 0 for A, B, and C, I'm going to get 4 like that, okay? So this is some test data. Yeah. It's real. Take out the rationals. The reals take out the rationals. So what's left? The irrationals. So this symbol means irrational, okay? Now remember that the rational number set is infinitely dense, and the irrational number set is infinitely dense. In other words, any two rational numbers you can name, there's infinitely many other rational numbers in between. And the same thing for irrationals, okay? So when I erase all the rationals, and I'm left with the irrationals, it's still a pretty big set. Okay, pretty dense set on the number line. Anyhow, let us talk about what we're doing. We're solving this. We're solving equations like this. A x squared plus bx plus c, where a, b, and c are just some real numbers, some real coefficients or constants. Let's make it easy. Let's make them integers. And we're solving by saying x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? All over 2a. But I'm going to write it this way. Is it the same thing? That's the same thing, right? I'm making the point that if this is a negative discriminant, you're going to get i's here. You're not going to get i's here, right? So this is going to be the real part. This is going to be the imaginary part from your complex number, like negative 1 plus or minus 1i. So I'm going to keep, when I'm writing the program, it's going to find it easier to break it up a little bit, okay? Okay, so you're ready to write your program? We're going to write a program called quad for quadratic formula. Okay, what does it do? First, it's just going to figure out the discriminants. Then it's going to figure out the real part. Then it's going to figure out the imaginary part. Then it's going to add them and subtract them and get the two roots. Okay? One thing at a time. By the way, I'm basing this on my book. This is my bestseller on eBay. I sell about 10 or 20 of these every month. Okay? 25 bucks a pop. Okay? Yeah. And let me just clue you in on the introduction to the teacher, okay? There's some stuff you might find interesting. Ready? At the beginning it says something like this. The first piece of advice I should give you when learning to program in general and learning TI basic in specific is to RTFM. What's that? Read the freaking manual. This is a technical term used a lot in Engineering 101. Stands for read the freaking manual. I'm serious, you really owe it to yourself to skim at least the programming chapter in the manual that came with your TI graphing calculator. You have a manual? There's a chapter in there all about programming. Take a look at it. I think it's chapter 8. Okay. If you don't RTFM, you're likely to run into a snafu, and you know what that means, don't you? No? Situation normal, all effed up. Okay. That's the beginning of it. Now here in the conclusion it says, well, without much further ado, I'll let you get into the meat and potatoes of this tech book. This is not a text book, it's a tech book. I made up that name. It's a book to be used with a textbook, but it enhances it. It adds all the stuff you do with technology, right? So technology, textbook, it's not funny, it's just a fact. Okay. It's time for you to dive into the code on the next few pages. When writing these programs, I have endeavored to follow the Computer Science 101 motto, KISS.
Keep it simple, stupid.
Keep it simple, stupid, right. This technical term stands for keep it simple, stupid. All computer science students follow this rule so as not to foobar their programs. F up beyond all recognition. And you wouldn't want to do that, would you? All kidding aside, if I inspire you to write your own code, I hope you follow the basic maxims of RTFM and KISS as well. Okay, enough jollity, as they say. So how are you going to write this program? Let's go to Hal, and let's write a program. All right, first thing I do is turn it on. Thank you. Now, the next thing I'm going to do is I'm going to create a folder for my work, because what happens when you run the program is it generates a lot of variables and it throws them into the folder that you're working. You don't really want all that stuff in one fat folder with everything all mixed together. So instead of just using main, I'm going to use a folder, call it quad or something. This is what you do. Go to second varlink, second minus. Okay, now look, I already have a bunch of folders in here. I already have a quad folder. You can call it quad. I'm going to call it quad 2 to pretend I don't have it yet, okay? And what you do is you hit F1 and you go to choice 5 to create a new folder. And you can call it quad. Now I think you're in alpha mode. It's hard to tell. Let's say alphabet. I think you're in alpha mode. So just go straight to writing, where is it? O, P, Q, right. Q and U and A and D. Now you're done. You can just hit enter, enter. You have to do it twice to make it stick. I'm going to write quad 2 because I already have quad. I have to change from alpha mode though. All right, so I have a quad 2 folder, right? Hit enter twice. And now I have a quad 2 folder. You have a quad folder, that's fine. Now I want to be working in that folder. I got to switch the working folder. If I go second escape is quit, notice the working folder is stated here. How do I change that? You got to go to mode, and it's the second choice, current folder. Just go down to current folder, change it to the one you made. I'm using this one because I already filled that one in. All right, this one's going to be an empty folder for me. And again, you hit enter twice when you're in mode. Now, let's write a program. Go to apps. Oh, what happened? Well, does it say quad down here? If it says quad down here, you're in business. You good? No? What happened? Where's the folder? What you do, okay, did you go to mode? Go to mode. Right below where it does function, all that stuff, it says folders. Go to the next second line. And then right arrow until you find quad. Okay, you got it? Highlight it. Highlight quad and hit enter, enter. Now in the bottom left-hand corner it should say quad. Instead of main?
No password that's set.
That's probably okay. Okay, all right. So, all right, so let's go to apps. Now, I have an older 89, so I don't have all the hieroglyphics and icons that you guys have. But pick the one that says Program Editor. Go to apps. Go to Program Editor. And then select, I did right arrow, select new. We're writing a new program, right? Now, I want it to be a program, so I'm not going to change that. I want it in Quad 2, so I'm not going to change that. I'm just going to give it a name. I'm going to call it, guess what? Quad. The folder is called Quad. The program is called Quad. All right, is everyone okay? Program, Quad, Quad, right? Enter, enter. And now what it does is it gives you the scaffolding of your program. All right, let me remind myself how I wrote this. There it is. Okay. All right, so I'm not going to fill anything in over here. You can leave that blank for a minute. I'm going to show you what that means later on. But let's write the program. Now, most basic programs, this is using TI-89 Basic. Basic is a programming language that's been around forever. I wrote my first basic program in 1975. I think it came out in the 60s. Basic stands for Beginner's All-Purpose Symbolic Instruction Code. It's a beginner's programming language. It should be easy. But what's different about this is that it includes all the TI-89 functions that you're familiar with, all the graphing functions, all the calculus functions, all that stuff. It's mixed together, so you can do all kinds of stuff in here that you can't do in standard basic. All right, so, but most basic programs have input and output. All right, so how am I going to input stuff? Now remember what I'm inputting. I'm inputting A, B, and C, whatever it is, like 1, 2, 2 or something, right? And I want to calculate the discriminant. That's where I'm going to start. Eventually I'm going to do this whole mess. Alrighty, so this is what you do. Do you see up here where it says I/O? You know what that means? Input-output commands. So hit F3, that's F3, right? Hit F3 and select, let's see, how about prompt? There's a lot of ways of doing input. Prompt is probably the easiest way right now. So go to prompt and hit enter. And what am I prompting? I'm prompting the user to enter alpha A, comma, alpha B, comma, alpha C. Enter. Okay, so I'm just prompting the user to enter those numbers, whatever the numbers are, from the equation. 1, 2, 2, 1, 2, 1, 1, 2, 0, whatever it is. Are we okay? That's it. It ends with C. Yeah, what's all this ringing going on? Okay. Now, most programs have input, process, and output, okay? There's the input. I need to do some output. All right, so go back to I/O. Where's that? F3. And I'm going to use the display command. It just prints out stuff. Display what? Well, I want to calculate the discriminant. So I'm going to do something called a function. A function is sort of like, you know, when you do the square root key, what happens? If you plug in 4 into a square root, what do you get? 2, right? So a function is just like that. You plug in some information, you get out some information. You plug in 4, you get 2. Well, this one is going to be called discriminant. So go to alpha D, alpha I, I'm not an alpha otherwise, right? Alpha S and alpha C. All right, I'm going to call the function disc, shorthand for discriminant, and I'm going to plug in, open parentheses, the values of A, B, and C that the user gave me. Alpha A, comma, alpha B, comma, alpha C. Close the parentheses. And that's the complete program for now. We're going to be adding to this. All right, so all it does is it asks the user to input some numbers, say 1, 2, 2. Then it's going to call the function disc. which processes the data 1, 2, 2, and then I'm going to output the answer. I'm going to display whatever the discriminant is, which means I have to write a function. I didn't do that. All right, now this is automatically saved, so you don't have to do anything to save it. Go back to apps. Everyone okay with this? Okay, it's just 2 lines of code. That's all it is. Okay, go back to apps. Go back to program editor, and go to new. Now I don't want a program. A program controls everything else. In this case, a bunch of functions. So go to right arrow and select function. A function is like a black box. You put in a number, you get a number out, let's say, okay? Like square root, right? In this case, discriminant, if I plug in 1, 2, 2, I should get -4. Remember the discriminant was -4? When A was 1, B was 2, and C was 2. All right, so it's a function. It's in quad. You have quad, right? But I'm going to call it what? Well, what did I call it? Disk. Okay, so I'm not in alpha mode, am I, or am I? Let's see, hit D. Is it a D? Yeah, you're in alpha mode. So hit D, I, S, C. I never know when I'm in alpha mode because sometimes when you are, it doesn't say it. Here it does say it, so you're okay. Okay, so that's the name of the function. Hit enter, enter. Now you're going to see what this is for. This is called a parameter list. This is where you put the input. I'm going to be inputting alpha A, comma, alpha B, comma, alpha C from the other program. Whatever A, B, and C was in the other program. It gets plugged in here. And what do I want to do with it? Well, you tell me. What's the discriminant? How do you do the discriminant? B squared minus 4AC. So just type that. Alpha B squared minus 4 times alpha A times alpha C. And it will automatically return whatever the discriminant is. Okay, you ready to test your program? That's it. This program has input from the prompt, output from the display, and processing from the discriminant function that we made up. So how do you run it? Well, everyone's got this? Can I move on? Okay, do second escape is quit. You get back to the home screen. If you're not on the home screen, hit home. And to run it, you do this. Second varlink, second negative, or second minus, and select the program, quad. Just down arrow until it's highlighted. Hit enter, and then notice it's got an open parentheses. It thinks you're going to input stuff here. I didn't do that, so I'm going to close that. Just highlight quad, hit enter, and then close the parentheses. It has an open parentheses. Close it. That's good. It should be in home, but it should say quad down here now. No? All right, well, okay. So now it has an open parentheses, right? You got to close it. No? I'm talking about this quad. There's a quad down here, which is your folder, and there's a quad up here, which is the program you're running. Well, you can always type it, alpha Q, alpha U, okay? Now, if you hit enter, look what it does. Now, ignore this gobbledygook. We're going to fix that later. This is output from a different program, the previous program I ran last month, okay? We want to clean that up eventually, but ignore that for now. What's A? Well, let's see. Let's do our test data. Let's go back here. If A is 1, and B is 2, and C is 2, the discriminant is -4, right? All right, let's see if that works. Okay. All right, so plug in 1, 2, 2. So look, it's saying, this is what the prompt command does. It waits for you to enter stuff. Prompt A, B, and C says A question mark, okay, 1, enter. B question mark, oh, what is it? Oh, it's 2, enter. And C, what is it? Oh, it's 2, enter. And it should say -4 when I'm done. Ta-da!
That's so cool.
Okay, that's good, but it's not very clean input and output screen. All that junk was sitting there. I like to label my answers. So what is -4? This is called a naked number. Yeah, we don't want that. We want to label our answers, okay, like discriminant equals or something, so people know what that -4 means, okay? So let's clean up this code a little bit, but let's test it some more. What if I do 1, 2, 1? I better get 0, right? Okay, to get out of this program output screen, hit F5. See where it says program output? So hit F5 to get out. You're back on your home screen. Hit enter to run it again. And now let's test this. 1, 2, 1 should give me 0. 1, enter. 2, enter. 1, enter. Does it give you 0? It does. All right, but see how messy this screen is? It had all kinds of junk on there before I started. I want to clean that up. So go back to apps. Go back to program editor. Now don't do new, do open. and I'm going to open the program. So leave this alone, leave this alone, leave this alone. There was only one program to choose from, and it defaults the program, so just hit enter. In other words, open. Not current, not new, but open. Okay, so it opened quad, right? Just open. Got it? Okay. Now I'm just going to add some stuff here to clean it up, okay? Before I ask for input, I want to clean the screen of any other junk that was there before I started. How do you do that? Well, I think that's in catalog. Go to catalog, and I'm already in C. Now say I'm not in C. I don't know. I'm over here. Wait, alpha. Okay. Say I'm in some random place in catalog. You can scroll up and down until you get to what you want. I want clear I/O. The quickest way to get there, though, is to hit alpha C and gets you to C's, and then you don't have to scroll too much to get to clear I/O. There it is. That clears the input-output screen. Okay? Now, what I also want to do is I want to label my answer. I don't want to just display 0 or -4 or something. So what I can do here is I can put a string that, like a bunch of words. I can put a sentence here if I want, but I got to put it in quotes. Now look where the quotes is. It's second one. It's not alpha. That's weird. Second one, and it's just something simple like alpha D. Right, I'm not an alpha, right? So alpha I, alpha S, alpha C equals, close the quotes, second one, and then a comma. All right, so what that does is it'll put it to 0, the -4 or whatever, but it'll label it first so you can see what's going on. Okay, so let's run it this way. You ready? What's that? I don't understand what. Yeah, some people have to do input right from the home screen. I don't do it that way. You can. You don't have to. Okay, so I'm going to leave it on. But I did that in disk. In disk, I had ABC in there, right? Okay. All right, any questions on this? How do you undo? You just backspace or whatever. What do you want to undo? Yeah, like what?
I pressed something. I was writing discriminant, and then it just went to that.
Oh, you're screwed.
You're lying.
You're screwed. You just got to do it again. F3, display, and then quote, and alpha D, alpha I, alpha S, alpha C, and quote, and comma. You have a comma now. Now it's back. See? But wait, it's not quad, it's disk that we're printing. Alpha D, alpha I, alpha S, alpha C, open close. Well, yeah, the open close. All right, that should be it.
There's no equal?
No. Well, you want the equal? Yeah, we put an equal in the quotes. Okay, so put equals, put a quote. Is the second one? There it goes. Yeah, that's it. Okay, so let's test it. Now, we already tested these two. Let's test this one. Remember that if we plug in 1, 2, what? What do we, for this one, what do I plug in? A is 1, B is 2, C is 0. It should get 4, right? Okay, so second escape, and enter. And A is 1, enter. And B is 2, enter. And C is 0. Now notice it already cleared out all the stuff from the other output, right? So there's a nice clean input screen. That's what I want. And then hit enter, and there's the discriminant. That's better. Discriminant equals 4, right? There it is. That's it. That's it for now. We're going to add to this. Yep, that's it for now. But wait, there's more. I want this stuff to go away once I'm done with it. How am I going to get rid of this so it just says disk equals 4? Do a clear IO again. All right, so program, apps, program editor. Yeah, let's do it again. Open.
It comes up as like a thing and line goes to this like a stupid rate here.
Yeah, you have a newer version, so you have icons to click. Highlight the program editor. It's a big difference. It's just hieroglyphics. You know, the more things change, the more they stay the same. They did this 5,000 years ago in Egypt, right? Did they have TI-89s in Egypt? I don't know. All right, so anyway, let's add this. What I want to do is I want to clean up my output screen too. So go to the beginning of the display line, hit enter, you're going to get a blank line. All right, in there, I'm going to put another clear IO. Now, if you go to catalog, it's already there. because we used it there last, so just hit enter and you're done. So have a clear IO before the input, then you do the input, and a clear IO before the output, then it does the output. Just makes life a lot easier to understand what's going on when you run it. Alright, so you got all that stuff? 1, 2, 3, 4 lines of code, that's it. Alright, second escape is quit. Hit enter to run it again. Let's do this one. 1, 2, -1 should give me 8. 1, enter. 2, enter. -1, enter. Does give me 8. Look how nice this is. The output screen is all by itself. Disk equals 8. Alright, there it is. Now, no, this isn't Windows. I don't think so. You want a shortcut on the desktop or something? No, I don't think so. Alright, now let's go back to this part. We've got the discriminant thing. Wait, over here. We've got this part worked out. B squared minus 4ac. But I want this and this. I want to calculate this, I want to calculate this, and then I want to add them up, right? Okay, so let's calculate this. I'm going to call this the real part. I'm going to call this the imaginary part. How do I find this? I'll make another function. Okay? So, go back to Hal. Wake up. Go back to apps. Well, let's get out of the... Well, it'll do that anyway. Go back to apps. Go to program editor. Go to open. And we're going to open quad. Just hit enter. It defaults to quad. And this is what I mean. I want to also print out what the real part of the answer. Alright, so go to the last line, the beginning of the last line, this end program, hit enter, you get a blank line, so you can add more stuff. Now I'm going to output the real part. Okay? So let's do a display line sort of like this. I'm going to say F3, display, quote, which is second one, real, okay, so that's alpha R, I lost my R, alpha E, alpha A, I hate this keyboard, alpha L. I should really be doing this on a TI-92, which has a QWERTY keyboard, so it's not a big deal. Where the heck is L? Is that it? Yeah. Okay, equals, close the quote, comma, and how about I make up a function called re, alpha R, and alpha E, of, now think about it, the real part only needs to know about B and A, right? That's all it needs. So I'm going to input alpha A, comma, alpha B. That's the only information it needs to figure out the real part. Okay? Any questions how that works? That's it for now, but we've got to write that function. Remember, that's a black box. I'm going to plug in A and B, and I'm going to get the real part out. Okay, so let's write read. Apps, program editor, new. It's a program. Is re a program? No, so change that to function. Is it in quad? Yes. What's it called? Re. Now I think I'm in alpha, so I'm just going to hit R and E. And see how it's not clear? Now it's clear, but before I started typing, it didn't say that. Okay, enter, enter. Now re has some inputs, right? What was it? A and B. So alpha, A, and alpha, B. Oh, sorry, there's a comma in between. And so how do you calculate the real part? Just type it. Negative alpha B divided by, now be careful, what am I talking about? What do you have to be careful about? Parentheses around the denominator. 2 alpha A. And that's going to be the real part. Well, wait, I don't need that. That's going to be the real part. Real part, that's it, done. Okay? Negative is the gray key down here. Negative is this, subtracting is this, changing the sign is this. This is a binary operator, it takes two numbers. This is a unary operator, you can work this on one number. Change one number sign. Okay, so let's run this. Okay, second quit. Now remember, we knew the real part of the complex root, right? When we entered 1, 2, 2, when we solved 1, 2, 2, look. When we solved it, the real part was what? If we enter 1, 2, 2, the real part was negative 1, all right? So if we enter 1, 2, 2, it should say real equals negative 1, right? Okay, let's try it. So I'm going to run it again. And I'm going to say 1, enter, 2, enter, and 2, enter. The discriminant is -4 and the real part is -1. So far, so good. Okay, now we're about out of time, so I'm going to stop here. We'll finish this up tomorrow. But this is just warming you up on how to program, so we can write a program for Newton's method, the stuff we were doing yesterday, right? All right, so finish this up tomorrow, and then we'll do a program for Newton's method. All right, so we're done. You're going to need this on the